Hi, hello everyone. This is your Raghavi Deva. I hope all are doing good. Today, we are going to see the topic is about electric dipole. Actually, dipole is nothing but two charges, right? Plus charges and minus charges. Here, electric dipole is when two point charges of equal magnitude but opposite sign are separated by the small distance. So that's the diagrammatical view. I clearly explained the minus charge and plus charge are separated by the small distance d, right? So this is the way our electric dipole will be formed. So in this electric dipole, where we will connect with real-time application means in antenna model of design, especially where we use our wireless communications, RF transmission line, satellite communications, wherever we in need of signal broadcasting and wherever we in need of antenna model of design, where the case we use this electric dipole. So let I clearly explain this electric dipole concepts with a diagrammatical view. So this is the diagram I just consider for my analysis. So by using the electric dipole, we are going to find the potential which is happen around the region, right? So for that I consider the electric dipole on the z-axis. So basically our analysis is to be make with x-axis, y-axis or z-axis, but here I just consider the electric dipole on the z-axis. So here plus charge and minus charge separated by the distance d. So due to that electric dipole formations, I have to find the potential which is happen around the region, right? So I just consider the point P. So in this point, I'm going to find the potential. So for this, I just consider the coordinate system to do the analysis. So basically, we have three coordinate systems, right? Rectangular, spherical, and cylindrical. So here I just consider the spherical coordinate system because here our electric dipole is spherically symmetrical, so I consider the spherical coordinate system. So basically, spherical coordinate system consists of three parameters like r, theta and pi. R is nothing but we are going to find with radius of that particular parameter and angle of the particular design, right? So in this we are going to find radius along with the angle value. So I just consider the point P, right? So from point P to point A. The plus Q marked as the point A, minus Q marked as the point P. So from point P to point A marked as the radius R1, and point P to center I just marked the radius R, and point P to point B I marked as the radius R2, right? So from point P to A, it will be provide one potential, and point B to B, it will be provide one more potential. So in this point P, we have to find the total potential. So for that, we have to do the sum up of point P to A plus point P to B, right? So as we all know, the basic formula of potential is Q divided by excuse me 4 by epsilon naught into r, right? So here due to point P to A, it to be written as Q divided by 4 by epsilon naught into r1. From point B to B, the potential can be written as minus Q because here we place the minus Q charge, right? So it to be written as minus Q divided by 4 by epsilon naught into r2. So total potential we have to sum up the two potential, right? So this is from point PA. We consider the potential V1 as Q divided by 4 pi epsilon naught into R1, and point B potential we can written as minus Q divided by 4 pi epsilon naught into R2. So in this we have to do the find the total potential. We have to sum up these two potentials. So finally we get the equations like this: Q divided by 4 pi epsilon naught 1 by R1 minus 1 by R2. So it is looks like a improper fractions. We make it in a proper one, we have to do the LCM. So after doing the LCM, these equations will be changed like this: Q divided by 4 pi epsilon naught R2 minus R1 divided by R1 into R2, right? So this radius of this R2 minus R1 and R1 into R2 we are going to find. So for the case we consider the same diagram with small modifications. What we done here means we are considering the electric dipole on the z-axis same as, but the point P, right, we choose around the region, right? The point P, from point P to A, point P to center and point P to B. So each radius is assumed to parallel to each other. So this is the analysis we done. One more modifications we done here. to find the R2 minus R1 value and R1 into R2, right? Okay, so in this analysis I just draw AM is perpendicular from A onto radius R2, right? So then it will be formed like a triangle from A, B and M point. It will be formed like a triangle. So from this triangle we can able to find the angle value, right? So here with respect to R1, R and R2, the angle made with the Z axis as theta, because all are assumed to parallel to each other, right? So in this analysis, I consider the triangle ABM. From this point, I am going to find the BM value. So BM can be written as the other side of AB along with the adjacent angle cos theta. So BM can be written as AB cos theta. So AB is your distance point, right? So here the distance is written as d into cos theta, and from our analysis I can able to find the whole distance of P to B point. It to be written as PM plus BM, right? So as you know BM value, so it may be rearrange the form of BM equal to PB minus PM. For that you have to know what is PB and what is PM, right? So from the diagram I can predict that PB is the radius R2 and PM is parallel to PA, so it to be marked as the radius R1. So I can substitute the terms for PB and PM. For PB I replace by R2 and PM I replace by R1. Then I can get the equations BM which is equal to R2 minus R1. So previously I find that BM value as d cos theta. So I can relate the two terms. So I can find R2 minus R1 as d cos theta, and R1 is parallel with R2, right? So with that understanding I can replace the term R2 minus R1 as d cos theta, R1 into R2 as R squared. So up to now I can find only the potential V, right? So I can find the electric field with the help of the potentials with the formula of minus del into V. So V we find that, and for del we have to replace the spherical coordinate uh, system replacement. So for spherical coordinate we have to consider r, theta and pi. With that I can replace the term of del as dou by dou r into r vector plus 1 by r dou by dou theta into a theta plus 1 by r sin theta dou by 2 pi into a pi. So for the terms of v I replace the q d cos theta divided by 4 pi epsilon naught into r square. So in this parameter we have to differentiate with respect to r. Yes, obviously we have r squared, we can able to find the differentiation with respect to r, and we can do the differentiation with respect to theta. So here we have theta terms also, cos theta we have here, so we can able to do the differentiation with respect to theta, but pi term is not available, so we can't able to do the differentiation with respect to pi, right? So if I do the differentiation with respect to r means 1 by r squared, I can able to do the differentiation. It to be written as r power minus 2. After do the differentiation it to be written as minus 2 r power minus 3. So I just replace minus 2 over here. R cube r power minus 3 written as 1 by r3, right? So likewise the same term I can differentiate with theta means it to be changed as minus sin theta. So for theta term I can replace by minus sin theta. After finding the terms I just do the substitution for r vector and theta vector. For pi we can get 0 value. So after do the substitutions, after do the multiplication of minus with all the terms, finally I get the equations like this: qd divided by 4 pi epsilon naught r cube into 2 cos theta r vector plus sin theta into a theta. So in this, that qd, the product of charges with respect to distance, to be called as dipole moment. So finally we find our electric field at a point P due to the electric dipole. So what is the plus and minus we face with that electric dipole connect with the real time application means. So if we say the plus means, it can be especially used for the antenna radiation concepts, helps to understand the polarization effects. But the drawback in the sense, it to be considered the distance between two charges to be as very small, it not to be valid for larger charge distributions. So for the case for larger charge distribution cases, we move on to alternate model, so method of images multiple expansion concepts. So I'll just give the alternate model of concepts in another video. I hope this can able to understand us very clearly. Thank you. Thank you so much.